My esteemed viewers, in this tutorial, we clearly explain a very important concept of any programming languages in general, of course, C here in particular. The concept is about user-defined functions or building user-defined functions or developing user-defined functions. Remember, C language library comes with several or multitudes of built-in functions that are defined in various header files. For example, stdio.h, math.h, conio.h, time.h, ctype.h, process.h, etc., etc. They are all defined respective functions which are appropriate. For example, math.h function contains all the mathematical functions. Conio.h is related to will have related functions which is specific to console input output, and stdio.h is all about standard input output. Time.h is all about managing time related aspects like random types, etc. And ctype.h will contain character type functions, and process.h will contain appropriate functions. The working of those functions will be seen if and only if, or the working of the functions, let us say in math.h, will be seen or will be observed, will be effective if and only if this math.h is included among the header files. The functions in C, actually we discuss about user defined functions in various forms. Of course, let us say when we organize a big event in the college, let us say the principal is the main let us say patron or main organizer or main coordinator, and it is a huge work. He assigns or delegates various other activities like stage management, proposing vote of thanks, proposing welcome, and arranging for food, and arranging for travel arrangements for guests and delegates, etc., etc. In the similar way, the planning of a large program is very much similar. First, we must understand the problem as a whole, then we must break it into simpler, understandable parts. We call each of these parts of a program a module, and the process of subdividing a problem into or a program into manageable parts is said to be top-down design. Therefore, a problem is designed using modules or functions, and such a design is called as top-down design. The principles of top-down design and which is in structured programming dictate that the program should be divided into main module and its related modules. Each module should also be divided into submodules according to the software engineering principles. Okay, the division of modules proceeds until the module consists only of elementary processes that are let us say intrinsically understood and cannot be further divided, and this process is called as factoring. In top-down design, a program is divided into main module and its related modules. As I said earlier, each module is in turn divided into submodules until the resulting modules are intrinsic. That is, I am repeating the same thing, until they are implicitly understood without further division, or they are further not divisible. Okay, we cannot further divide. In this essence, a function top-down design advocates that a program should be divided into modules. Further modules are again divided into submodules. Okay, the breaking of a complex program, simply told. By definition of a function is an independent block of program written to render a particular task, that is some computational task, and it gets executed if and only if it is called to do so. Okay, the main function, the function which calls a subfunction to come and execute and to return the answer possibly is called as a calling function, and the function which gets executes under the insistence of the calling function is called as a called function. And let us say this is the main module, and of course the structure chart can be written something like this, how exactly the structural program works with several functions that are developed. So it's a complex program. Of course, for a simple program like adding two numbers, there is no concept of developing a function doesn't hold water. Here is a main module, and main module has a huge work. Therefore main module is further divided into module 1, module 2 and module 3 separately, and they are given different names. Of course, the different names given to a function or a module will befit or will tell us as to what this function is doing. And module 1 probably having much work. Once again, it delegates different components of the work which are unique to a module 1A under this umbrella, module 1B and module 1C. And similarly, in the same token, module 2 is further divided, and so also module 3, which is also further divided, and they gets executed, and they will transfer their return value or the answer and whatever that is computed to the module 1. Okay, of course the delegation of the functionality flows in the downward fashion. Structure chart, or this is the module breakup chart, and here is these are all called as modules, and these are all calling modules. Okay, these are all calling modules. Okay, module 2A, module 2B, module 2C are being called by module 2. So also module 3A and module 3B are called by module 3. Okay, accordingly they are named. Of course, here they are named, and this is the way in which control will flow, and this is the way the functions are designed. Anyway, there exists one and only one main function in any C program, and main function can be broken down, and the communication between functions will happen. Only two functions will be communicating at a point of time. Okay, communication happens only between calling function and called function. The communication in that sense, if this is the main function, and if it has module 1, and if it calls, communication should happen between main function and module 1. And the communication, by communication we mean the passing of the control. Okay, when the control is passed, in some cases, in most of the cases, of course, control will be passed along with the data. Okay, the module 1, in order that module 1 works, main function, the calling function, should supplement this module 1 with data, and it has to hand over the control. Now module 1 will be triggered, and it will be in execution. It will occupy the main memory, and module 1 has something to compute separately, and it wants to use that particular computational value. Therefore it will delegate some portion of the computation to module 1A. So therefore it passes the control to module 1A along with the data, along with the ingredients. They are called as arguments, they are called as parameters. Okay, and using this it will compute, and it finds some other work to be delegated to another function which is under the control of module 1A. So module 1A is a calling function, and module 1A point A is the called function. Once again, here module 1 is the calling function and module 1A is the called function. The communication is established between module 1 and module 1A. Okay, and main will be in oblivion. Main will be oblivious of what is happening between module 1 and module 1A. So also module 1 will be in oblivious and it doesn't know as to what is happening between module 1A and module 1A. This is called as nested functions. Okay, module 1AA, because since this is being the last function in the nesting, it will compute whatever that it is asked to compute, and it will return the answer or return the computed value to its caller. Okay, the module 1A. So module 1 will make use of this returned value. It may further continue, and it will just just develop some kind of an answer or some kind of a computation which should be returned to the module 1. So the flow of control will be in a reverse way. When the functions will gather the computational or the computations that are rendered by different functions. Once again, module 1 will compute in its totality and it will return the value to the main function, that is calling function, and the main function will make further use of this particular returned value, and it may continue processing, and finally it will come out with the final answer. So anyway, if you take a function as a box, it is not a black box anyway, because we can see what is happening, and it can receive theoretically a function can receive any number of parameters or any amount of data. It is schematically shown over here as if there are 5 events in order to pass this particular 5 data values. Theoretically it can be anything, it can be any number. So this data will go inside the computer. It will go inside a function, and it will be used, and some computation will take place, and after the computation a function can return only one value. This is a very important point to remember, and it can if a function wants to return several values, it can return a structure. Of course we will discuss about a structure in the later tutorials, okay, the coming up tutorials. And a function theoretically or by default, a function can return only one value, and if a function wants to return several values, it can return a structure, because structure will encapsulate several data parameters or data values. And with a pointer, if a function which returns a pointer, of course a pointer concept is also yet to be discussed, and it will come up in our next tutorials, okay. And if it is returning a pointer, it would mean that it is sending huge amount of data through pointers. By default functions, a typical function will be able to return only one value at a time. There are several advantages in developing functions or in a programming environment. Of course, as programmers, we should learn how to build functions, how to develop functions. Our program should be functional. It should be function oriented. For every different task, we need to construct functions. That comes in the structured programming style. Let us say, already said, huge sized problem or a complex problem can be factored into manageable steps with the development of functions, and they are factored in such a way that they are easily understandable and easily manageable. Functions provide a way to reuse the code that is required in more than one place in a program. Assume, for instance, that a program requires that we compute the average of let us say series of numbers in 5 different parts of the program. Let us say, had there been no function concept, this would have done this way. Each time the data are different, let us assume, we could write the code to compute the average of 5 times, but this would take lot of effort at 5 places, let us say. Also, if we needed to change the calculation, we would have to find all 5 places that use it to change each of them. It is much easier to write the code once as a function and then call it whenever we need to compute the average. Let us say there is a question of computing average at several places in a program with different values. Therefore, we will construct only one function and we will pass the different values, and we will call the function whenever average is to be computed, instead of writing the program again and again. So therefore, there is a function that is developed which is reusable. Reusability concept is a very important concept, okay. The advantage in using functions is closely tied to reusing code. Like many languages, C also comes with a rich and valuable library. For example, there is a math library, as I told earlier, MathH, that contains almost any mathematical or statistical function that we will ever need. These C libraries provide standard functions that make our work as a programmer much easier. We can also create personal and project libraries that make developing systems very easier. Another important aspect of functions is functions protect the data, not in terms of logins. It is really conceptual. This is a rather complex idea that centers around the concept of local data. Local data consists of data described only within a function, let us say, okay, specific to the computation involved by a function. These data are available only to the function and only while the function is getting executed. Okay, whenever the function is in CPU or in the main memory. When the function is not running, the data are not accessible. Data in one function then cannot be seen or changed by a function outside its scope. This is what we mean by functions protecting the data. And with several functions, usually a big software is developed by making it into modules, and a group of people will be assigned with the development of the module, and they will independently work in groups, and it is very easy for them to identify any bugs that may creep in. So there are 4 kinds of functions that will come in the programming circles. Okay, there are only 4 kinds of functions. There is no confusion as such. First one is non-receiving and non-returning. This is the simplest form of function. They don't receive any data from the calling function, nor they return any computed value. For example, there is a function which is called by a calling function. It only displays a message. Hello, how are you? Maybe that may be the message. So it will do the allotted task or the designed task, and it will wane away. Okay, non-receiving and returning. These kind of functions do not receive any data from the calling function, but they return some computed value to be used by the calling function further. Okay, and the third kind of function is more prevalent in programming circles. They receive and they may not return. They receive the data, they may not return anything to the calling function. And the fourth one is widely used. They receive data from the main function or the calling function, and they do return some computed value to the calling function back in order that the calling function proceeds further, making use of the value that is being sent by this called function. So we will go one step by step way, and we will just dissect as to how we will thoroughly understand as to how this first category of functions do work, and what are the situations this kind of functions can be developed in programming environment. So non-receiving and non-returning function will function something like this. There is a calling function, say main or any other function, sub-function of a main. Okay, it's a calling function. So calling function will call another function. Okay, it will pass only the control. It will only pass the signal. So receiving the control from the calling function, the called function will do whatever the task that is being written or that is being coded, and it will come out with the output. It may display the output, and it will wane away. Okay, and that is the only thing that happens between a calling function and called function. It would say, hey, do this work. That's all. That work that is to be done by this called function is in the name itself, message. Okay, or display the message. That can be the name of the function. Okay, or compute is the function. What is to be computed? Only this called function knows. It will compute, and it will display, and it will wane away. Of course, it will return the control. Control will be returned back to the calling function because the main function has to proceed further. It will not, the program will not be stalled here after the execution of the called function. Okay, we will go through examples in order to reinforce our understanding about this kind of functions. Example 1. Here it is. We have a function written over here. This is called a function. During its lifetime within a program will enjoy two pride of places. One, at the calling stage. Here the function is called. Go and execute. That may be the instruction by the calling function. So calling function is main here as far as this example is concerned. And the other place where the function is mentioned or given a place is called as prototype. The function is to be declared because compiler should be made known beforehand as to what kind of function is coming. Okay, so this is a function which returns nothing, void. It returns nothing, and the name of the function is function1. It carries no data, but brackets are required and semicolon is required. Okay, put s. Okay, we are using this particular string function and we are not using printf because it is only a literal constant. You know what do we mean by literal constant? It has been elaborately discussed in string management. Okay, me main calling function1. This will appear. Then the control will go to function1. Okay, the third place where function1 will be seen in program is, okay, this is the calling function. This is the calling stage. Okay, and here function1. This is the definition of function1. What function1 has to do is defined over here. That means it is coded over here. Code is written. Okay, defining of the function means coding of the function. That is writing the portion, the program because this should look like an independent unit. Now control has already been over here. As soon as control comes over here, it will see a declaration function void function1 sub, because it is a sub function of function1. Okay, before control is passed to function1 sub, it will display this me function1 delegating the work to sub function. So sub function1 is called, function1 is called. So for function1 sub, function1 is the caller and this is the called function. Some authors do call it as a kali. Function1 sub is a kali. So void function1 sub, this is defined, that is code is written, and it is wrong to put semicolon over here. Okay, the control will die a natural death if you put a semicolon, and it may herald error also. Okay, here it is written me function1 sub not receiving anything from function1. Okay, function1 put as nor I am returning anything. Okay, so when this is executed, so definition of functions, this is called as definition of the function means writing the code or defining what it has to do in terms of code. So now output is like this: me main calling function1, me function1, because the control will go over here after printing this, me function1 delegating the work to sub function, me function1 sub not received anything from function1 nor am returning anything. So we will see chain of functions, and this is called as nesting of functions. One function inside another function. Theoretically there is no limit. We can keep on, but it is very confusing. We should avoid nesting the functions. Okay, example 2, let us see this. It will compute simple interest. Okay, these things are defined: float, principal amount, term, number of years, okay, duration up to which the principal amount is kept, rate of interest, and simple interest. Void calculate. So this will not receive anything, but it will calculate. Okay, clear screen, calculate function is called. Calculate function is called over here. Okay, after calling I am the main. Okay, enter the principal, term and rate of interest. Everything is entered. It will calculate and it will print the interest. Okay, calculate. Look at this function. It is doing some other thing. Okay, the main function is doing some other thing. Okay, it is calculating simple interest, and this function which is being called by main function is doing something, because that may be the demand in the program. Float length and breadth, void compute. This is the prototype. Compute, here is a calling for the function. Okay, so calculate function will call another function called as compute. Put as am calculate here. Enter length and breadth of the field in meters. So percentage of length and breadth of the field. That is agricultural field, let us say. Area of the field is percentage of length into breadth. Okay. Now, so first of all, this is executed because this surfaces in the beginning, calling function. So control will be passed over here, passed to compute. Compute will get executed. Okay, it will do mass and weight. Okay, mass and weight is read, and it computes the potential energy. So it computes the potential energy. Look at this. It is doing some other task. Okay, it is unmindful of what exactly its calling function is doing, because it is not returning anything. It is simply computing. It says faithfully yours. The potential energy, mass, mgh. It is computed and it is printed. So this example shows in printf statements also small amount of computation can be done. If this expression is complex, it is not desirable that complex expressions are written within printf. Okay, this is another learning. Okay, so compute is called by the other function, that is calculate function. Calculate is called by the main function. So that's how it works in a chain. So here the control will be passed to calculate. When the control will comes over here, the control will be passed to compute. Okay, compute gets executed. Therefore, in this chain, it is the compute function which will first occupy the main memory or CPU or the processor. Okay, as far as the CPU or processor is concerned, a function is a process which is in execution. Okay, when a function is getting executed in CPU, the calling function will go to secondary memory. It will go to dormant stage. Okay, right. This is how the things are moving. Control is moving as far as the previous example is concerned. Main has calculate function. So calculate will transfer the control. So control will come over here. So it sees compute, another function being called, and control will move to compute, and it computes and displays. And once again it looks at this delimiter, the closing flower brace, and once again it will go to the line very next to compute. So the process is completed, and it will come out with some value. It will do all the task and it will look at this delimiter, and the control will be passed over here, and the remaining part of the work in the main is computed, and it is completed. And when the control looks at this delimiter, it will hand over the control to operating system. So main will receive control from the operating system after the entire work is over, after the program is completed in its entirety. It will re-hand over the control it received from the operating system to operating system. Therefore, main receives control from operating system and returns back the control to the operating system. Okay, the output is displayed over here. Am compute here. Enter mass of the body and height it is placed. Okay, because this is the last function that gets executed in the beginning. Okay, the potential energy is so and so. Am calculate here. So the next the calling function of compute will get executed. Enter length and breadth of the field. Okay, so something answer is displayed over here, and the control will be passed to the main function. I am the main. Look at this. Main is getting executed in the last instance, and calculate is getting executed before execution of the main, and it is compute function which gets executed in the very beginning. So if functions are nested one inside the other, it is a function which is deep inside the nesting will get executed first. Okay, example 3. Here we have once again non-returning type of functions because it is void, it is written over here. These are all prototypes. Result declared 1, results declared 2, result declared 3, result declared 4. All these 4 functions will declare the results depending upon the input. Okay, so the main function has these parameters: mark 1, mark 2 in 4 subjects, and total and percentage of marks obtained by the student. Enter the marks in 4 subjects. So marks are taken, they are integers, total is computed, total is also an integer, then percentage equal to total divided by 400. This is to be done. If you do total divided by 400 without this decimal point, without this period, then what we get is 0. Or if the student gets 399, still he will get 0, because we have understood integer division results in truncation, and this is calculated, percentage is calculated, is multiplied by 100. Okay, that you know. Okay, how percentage is calculated. Now depending on the percentage value, if percentage is less than 35, result declared 1. A function call will be made. The name of the function is result declared 1. If percentage is greater than or equal to 35 and percentage less than 60, result declared 2. So these functions are used only to declare the results based on the condition. If percentage is greater than or equal to 60 and percentage is less than 70, result declared 3. This is called, and you can write before the if statement, or you can press enter and you can write under the ambit of every if statement. Or by writing this, we are showing some kind of a brevity when we write the program. If percentage is greater than or equal to 70, result declared 4. So control will come over here, it will question the percentage marks, marks will be compared. If it falls less than 35, then immediately control will be passed to result declared 1. In result declared 1, we have written this way. This is what it will do. Printf fails. Sorry, don't get disheartened. Work more this time. It will display this and wane away. It's not sending anything to the calling function. Why result declared 2? If the second condition happens to be true, then it will declare the result as second class, and it will give some consoling remarks. Fine, but scope is there for improvement. Try for the first class next time. Void result declared 3, print a first class. Very good. Try for still more. Okay, that is the thing which it does. It displays. Okay, result declared 4, distinction. Okay, slash, and this should have been double quote. Okay, I changed it. Sorry. Okay. Okay, printf excellent, sweets, keep it up. Okay, it is enter the marks in 4 subjects: 90, 100, 99, 97. Distinction, excellent, sweets, keep it up. So it is the last function which did work. Okay, that is not nesting, of course. This is not example for nesting of functions. Every function is aloof. Every function is not inside another function. All the functions are, of course, inside main. They are independently called. Okay, depending on whether a particular condition is met or not met. Example 4. This is another example where we have 4 functions: try, wish, congrats, and conclude. Percentage is the input. What is your percentage mark in PU? Percentage of percentage. Okay, if percentage is less than 60, 60, try. Greater than or equal to 60, less than 70, wish. Greater than or equal to 70, congrats. Congrats is the name of the function. So at any point of time for a given input, control will either go to try or go to wish or go to congrats. There is no question of all the functions working in line for a given input. Okay. Why try? This is what we have written. Try next time. Conclude. Conclude is another function which is being called by try. Wish. Printf, wonderful, but you may have to work harder. Conclude. Because conclude has to do similar kind of task, whether it is try or whether it is wish or whether it is congrats. Congrats would say congratulations and conclude once again. Okay, at any point of time, either control will come over here or here or here. We don't know. It all depends on the input given. But anyway, conclude has to work. And in conclude, we have written, instead of writing at several places, thanks for responding. Okay. Right. Output, what is your percentage of marks in PU? 66%. Wonderful. But you may have to work harder. Thanks for responding. This thanks for responding is displayed by conclude function. Okay, example 5. This is altogether different kind of a function. It's once again non-returning function, non-receiving function, all right. And you can see function being written before main. The name of the function is message. Okay. It is not returning anything, that is also not mentioned, because we want to do what exactly whether you tell it or not tell it, what exactly a function in C will do, what exactly it is going to return. If you write void, you are imposing that this particular function has to return nothing. If you don't impose over here, every C function, whether we like it or not, will return some integer value. Okay, therefore, and it is not wrong if you write int message. Okay, and you can write like this also, because typically any function, any C function, okay, without having set convention, by default will return an integer value. So clear screen is written so that this will be appearing on a clear screen. Put as I am defined above main. My place of definition comes before main. I need not be prototyped. If you want to avoid writing prototypes because of your forgetting nature, then define the function above the main. Okay. Then get ch to hold the announcements that is being made by message, or statements that is being made by message function, and here comes the main, calling message function. So immediately main, as soon, anyway, in the very first instance it is main. The function starts executing only from the main, and there will be one and only one main in every C program, that we know. Okay, so control will come over here, it will look at this calling function, the control will go over here and this will get executed. Once again, upon looking at this flower brace, the control will come back and it starts executing from here. Message function actually returning %d. Message function actually returning %d. See, you see what is that we have written? Till now we used to write a variable or a small expression over here. Now we are writing the function itself. Okay, get ch. Now we will see the output. Okay, this is executed. I am defined above main. So this is the statement heralded by the function which was placed above the main. I need not be prototyped. Now this is being displayed by main function. Message function actually returning 13. If you run this program once again, it may return some other value, but it is an integer. So every C the learning here is every C program, every C function, okay, so-called non-returning function will return actually an integer value which is unknown to the programmer, what exactly it returns. So how exactly a computer or operating system manages nested functions? That is the thing that is to be understood. Okay, this is the main function. Main function calls main function. As soon as it calls the function 1, the address of main function will be placed in a data structure called a stack. Address of the main function. So function 1 calls function 2, let us say. When function 2 goes for execution, before function 2 goes for execution, the address and return value of function 1 is kept in the next plate. You should see over here, plates are going in upward direction. The addresses are stored in a containers called a stack in an upward fashion. Okay, function 2 is calling function 3, therefore the address and return value of function 2 is stored over here, and function 3 is called, function 3 gets executed and its address and return value of function 3 is over here. So therefore the stack is built something like this. First main, its address. Second, the function called by the main. Third, the function called by function 1. Fourth, the function called by function 2. And when before you get the final answer, anyway final answer is to be obtainable from main, this is how it culminates. Function 3 returns its control to function 2 along with some value. No, it doesn't send any value because it is a non-returning type of a function. It will simply hand over the control to function 2. Function 2 will hand over the control to function 1. Function will hand over the control to main function. So main function will hand over its control to operating system. And this main function may come out with some output or some announcement or some message. This is how nested functions work. So we saw in this tutorial how exactly a non-receiving and non-returning kind of functions really work. And these functions are rarely used in programming circles. If at all you want to build a menu let us say, I think these kind of functions are the best. And if those functions are to be executed, different things, okay. Maybe non-returning type of functions can be kept in a switch case construct, okay, for calling, and there will be a fine menu. Okay, if the user selects a, let us say, first item in the menu, the control will go to the respective function. Some computation will be done over there, and it will just display and just wane away. Or if we select the second one, the corresponding function can be called. Okay, that is the only significant occasion where this non-returning and non-receiving kind of functions are useful in programming circles. But anyway, things remain. The thing is, any complex program should be broken into different independent modules, and this is the first kind of functions that we discussed. In the next tutorial, we will take up threadbare, the next kind of functions, the second type of functions, okay, that is non-receiving but returning, or whatever that we have listed. Okay, until then bye. And if you liked this video, I request my respected viewer, my esteemed viewer, to subscribe to my channel.